Okay, in this video for section 6.3, I want to talk a little bit about sampling distributions. There's really not a lot to this section, but it's actually one of the more important sections of this course. What sampling distributions are is you look at all of your sample data and then look at how that data is distributed. For example, let's talk about the mean of the sample means. Let's say that I wanted to find the sample age or the mean age for students in a classroom. So I can go to Decary 201 and find the mean age for one room. And then I can find the mean age of another room. And I could find that mean age for another room. And then I took the mean ages of all of those means. That would tend to target the actual population mean of the average age of people at UNE. So again, I'm taking my smaller samples and I'm finding some parameter or from some statistic from those samples. And then I'm looking at the mean of those samples, and that's going to tend to target the actual population. There's no bias to this, meaning that it's not going to underestimate it or it's not going to overestimate the actual population parameter. This works well for three things: the mean, the variance, and the proportion. Let's say I wanted to take, or the question was, what is the proportion of men and women at UNE? So it could go from one sample and find the proportion of men and women in one sample, go to another sample, find the proportion of men and women in another sample, and let's say I did 30 samples. And then I took the mean of all of those proportions of those samples. So I averaged all of that up. So I could have 50% men in one room, 55% in another room, 60% in another. And then I take all of those percentages and I take the mean of those percentages. That's going to target our population mean for that proportion. Also works good. So it works for the mean, it works for the proportion, and it works for the variance. This process does not work for the range, does not work for the median, and most importantly, it does not work for the standard deviation. If I took the standard deviation of ages in one room and compared it and took the standard deviations of another room and the standard deviations of another room, and I took the mean of all those standard deviations, that would tend to underestimate the actual population standard deviation. So we're going to learn a little bit later on how we're going to change our z-score formula in order to compensate for that bias using something called the central limit theorem. And that's it for section 6.3. We're taking sampling distributions and we're taking the means of those sampling distributions to estimate our population parameters.